Hey everyone, this is using the unit circle part 3, and I'm going to do a little bit of a different format. So I'm going to show you a couple quick examples and then give you one to try, and we're going to do that 4 times. So the first thing is being able to find negative 45 degrees. I'm going to give you 2 ways to do this. So the first way is the starting point is always right here, the positive x-axis. So if you know that positive 45 degrees is basically going to the middle branch of that first quadrant, negative 45 degrees means that you are just going in the other direction, but the same distance. So 45 degrees, you're going to that middle branch, or you can count 1, 2 branches. So you're just, again, starting at 0 and going 1, 2 branches in the clockwise direction. So to be very clear, negative 45 degrees is located at that magenta highlight. So right here is negative 45 degrees. If you do not like that, the other way to do this, and if I'm remembering, we did start this and worked on some of this, I think, when we were at Noble together, that you could add 360 degrees to find what's called a coterminal angle. Basically, that adding 360, you're just spinning in a complete circle, so you're going to end up in the same place. And look at what happens when you do negative 45 plus 360, you get 315 degrees. And so that approach, you would just be looking for, where is 315 degrees on the unit circle? It's right here. So negative 45 is coterminal with 315. No matter which approach you take, you want to just make sure you're getting to that location on the unit circle, either going in the negative direction or the positive direction. Okay, so that is the first one. The second one we're going to look at is negative 150, and then I'm going to let you try one. So negative 150, first you could do the idea that you're going to pass the first quadrant and then to that third branch. So you're going all the way through a quadrant, and then you're going to the 1, 2, third branch of the next quadrant. However, that's the positive direction, and you are trying to get negative 150. So you would just have to do that same thing, but in the opposite direction. So go through the first quadrant, and then go to the first, second, third branch of the next quadrant. And here's where you would be. So 150 in the positive direction is 150, but in the negative direction would be right here, what is highlighted in magenta. So that's one way if you like that approach. The second approach would be that if you don't like working with negative angles, then you could add 360 degrees. And what happens when you do that? You get 210 degrees. So if you don't want to move in the negative direction and find your way that way, if you add 360, you'll find out that negative 150 is coterminal with 210. Again, spinning in a complete circle, you're going to end up in the same place. So 210 and negative 150 are coterminal. They're both going to be on the same branch of the unit circle. And if you were doing positive 210, then you're just starting at 0 and going to 210. And you can see that label is there. Okay, so either one of those approaches to get to the branch that I have highlighted in magenta. And then the one that you are going to try, let me leave these examples up if you need to see them. You're going to look for negative 120 degrees using either one of those approaches. So I'm going to pause here and let you see if you can locate that on the unit circle. Okay, so negative 120 degrees is going to be using our first approach. Let's see, what's 120? 120 is all the way through a quadrant and then to the next branch. So in the negative direction, it would be all the way through a quadrant and to the next branch. So you would be here. That is negative 120. If you wanted to find a positive coterminal angle because you prefer positive angles, negative 120 and 360, you get 240 degrees. And again, you can see that's 240 degrees. If you're using positive 240, then you're just starting at 0 and going to positive 240. You just need to know that this is where you are ending up for negative 120. All right, the next section I think is going to be a little bit easier because of everything we just did. So let's start with number 1 again, 570 degrees. So this one, if you go all the way around the unit circle, starting at 0, if you go all the way around, that's 360 degrees. However, 570 means that you kept going around. So you went 360 degrees and then you went some more to get to 570. So you made more than one revolution around. And so I don't like working with those larger numbers. So I actually, for this one, I usually just take one approach, and that is I take 570 and would just subtract 360. So again, the minus 360, you're moving in a complete circle, so you're going to end up in the same place. And so that tells us that 570 and 210 are coterminal. They're on the same branch of the unit circle. And where is 210? 210 is right here. Okay, so that would be my only approach for a question like that. And one more of those would be 495 degrees. Again, it's beyond 360, so you've gone all the way around and then some more. And so I would just subtract 360 to find a coterminal angle, and you get 135 degrees. So 495 and 135 are on the same branch of the unit circle, and that is located here. And then one for you to try would be 660. So I'm going to pause here and let you see if you can find where that would be on the unit circle. If you subtract 360, you get 300. So those are coterminal. And where is 300? 300 is right here. All right, so then we are going to do basically the same thing, except we're going to move into radians now. So I'm going to take negative 2 pi over 3. So 2 pi, and just repeating myself, sorry, it's the same examples that we just did. The only difference is that we're using radians instead of degrees this time. So positive 2 pi over 3 would be starting here. Let me use that orange color I was using before. You're starting here, and positive 2 pi over 3 means you're going through a quadrant to the first branch after that. And so in the negative direction, you would do that same distance, but in the negative direction, through a quadrant and to the next branch. And so this would be negative 2 pi over 3. If you did not like working with the negative radian measure, we're going to add 360. This time, though, because we're in radians, I'm not going to convert to degrees and work in degrees. We're going to stay in radians. So 360 degrees is the same as 2 pi radians. And so you're going to add 2 pi radians, and that's the same as adding 360. This requires you to find a common denominator. And so we're going to use 3 as our common denominator and multiply by 3 over 3. So we get negative 2 pi over 3 plus 6 pi over 3. And that leaves me with 4 pi over 3. And then if you're looking for positive 4 pi over 3, that means you are starting here and you're just going to 4 pi over 3, right? You can just see that branch is labeled 4 pi over 3. So that is the first example. And then the second one, I'm going to show you negative 5 pi over 4. So that first approach is, where is 5 pi over 4? If we were doing positive 5 pi over 4, which it's not, but if we were, we would go through the first quadrant, the second quadrant, and then to the middle branch. And that is positive 5 pi over 4. If we're going in the negative direction, we're going to do the same thing, but in the clockwise direction. So through the first quadrant, through the second quadrant, and to the middle branch of the next quadrant. So that is your negative 5 pi over 4. If you really dislike that, you can add 2 pi. And this time your common denominator is going to be what? Would be 4. So we multiply by 4 over 4. We get negative 5 pi over 4 plus 8 pi over 4, which is 3 pi over 4. And then that's positive 3 pi over 4. So then you just look for where is 3 pi over 4? There it is. Okay, and then the one for you to try is negative 11 pi over 6. Okay, with our first approach, you can think about 11 pi over 6 is going all the way around and stopping at the very last branch before we hit that first revolution. So in the opposite direction, you'd be going all the way around and stopping at that last branch before a full revolution. So you might locate it that way. If you really dislike that, then you can add 2 pi. What would our common denominator be in this example? It would be 6, so we're multiplying by 6 over 6. We get negative 11 pi over 6 plus 12 pi over 6, which is 1 pi over 6. Where is pi over 6? Is right here, right? Positive pi over 6, you're just going to that branch labeled pi over 6. So either way, we get to the branch that's highlighted in magenta. And then the very last section of this, we will do 11 pi over 4. Okay, so if you go all the way around the unit circle, that's 2 pi radians, or 360 degrees. Think about 11 over 4. 11 over 4 is more than 2, right? 8 over 4 is 2. 11 pi over 4 is more than that. It's around 3, a little bit less than 3. So it's around 3 pi-ish. If you don't like what I was just saying, you would also notice that 11 pi over 4 is not on the unit circle. You've got 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, right, all the way up to 7 pi over 4. And so for these, you actually could keep counting if you wanted to. Let's go back to that, going around the circle by 4s. 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4 would be here, 8 pi over 4, 9 pi over 4, 10 pi over 4, 11 pi over 4. So here's where I'm ending up. That's 11 pi over 4, but it's more than one revolution around the unit circle, so you could also subtract 2 pi. In the examples we did before, we subtracted 360, right, to find the coterminal angle. Same thing here, we're just in radians, that's all. So we're subtracting 2 pi instead of 360 degrees. The common denominator here is going to be 4. So you've got 11 pi over 4 minus 8 pi over 4, which is 3 pi over 4. Where is 3 pi over 4 on the unit circle? I'm just going to take out some of that the markings were covering it up, but 3 pi over 4 is right there where we had found before. And then the last one I'll show you is 17 pi over 3. 17 over 3 is around 6 pi. So that is multiple times around the unit circle. So I'm going to subtract 2 pi. That common denominator is going to be 3. So we're multiplying by 3 over 3. We get 17 pi over 3 minus 6 pi over 3, which is 11 pi over 3. This is still not something on the unit circle, and 11 over 3 is a little bit more than 3. So it's a little bit more than 3 pi. Remember that this goes to 2 pi as one revolution. So if we know 11 over 3 is a little bit more than 3, we actually have to subtract again. And then instead of using 2 pi, I'm going to just use the one with the common denominator already. So 2 pi with the common denominator is 6 pi over 3. And that brings me to 5 pi over 3. 5 pi over 3 is on the unit circle, and it's right here. So I have located that branch of the unit circle. Last one, and we are finished, is 19 pi over 6. If you want to go ahead and try that one on your own. So for my people doing some mental math, 19 divided by 6 is about 3, a little bit more than 3. So a little bit more than 3 pi. I know that I've gone around the circle more than once. One time is 2 pi, around 3 pi. So I've gone around more than once. I'm going to find a coterminal angle by subtracting 2 pi. My common denominator in this example would be 6. So I've got 19 pi over 6 minus 12 pi over 6, which is 7 pi over 6. And is that on the unit circle? 7 pi over 6 is right here. So we're talking about that branch of the unit circle. The next video is going to use this idea, so you'll see some more reinforcement coming up on the next video as well. Great job.